Unsteady flow or transient flow process. Unsteady flow process is just like closed process, except there is also one way entry or one way exit of mass, और जितना मास एंटर उतना एग्जिट नहीं कर रहा है, या सिर्फ मास एंटर कर रहा है या फिर सिर्फ मास एग्जिट कर रहा है. चार्जिंग ऑफ अ रिजिड वेसल फ्रॉम सप्लाई लाइन, pumping of air into a balloon. Whenever a mass enters a system, it is an open system, and when mass only enters or when it's only exists or जितना एंटर किया उतना एग्जिट नहीं किया, तो then it is an open system, and that too unsteady. Due to unsteadiness, there is accumulation of mass in the system in the control volume. So accumulation of mass in the control volume per unit time is equal to mass entering per unit time minus mass exiting per unit time. If there is just mass entering, then mass exiting per unit time will be 0, and if there is only exit, then entering will be 0. Energy accumulation in the control volume. So here of course there is universal law, there is energy conservation, but we have to twist the form for here, because the control volume also keeps some amount of energy, because E is equal to mc square, mass is also energy. So in the form of energy, it stores some of the energy control volumes. For case like this, mass inlet and mass exit are different, so this is case of unsteady. So there is a energy accumulation, energy entering plus heat entering to the system, energy exit or work to the system entering exit. You just do it, means it was like energy exit minus energy outlet. Work CV is we have taken positive, but if work is done by the system on the system, you can of course do it. First law of thermodynamics for open system, this is the thing. First law of Q, take the वो मतलब क्या पॉजिटिव नेगेटिव, और यहाँ भी वर्क को पॉजिटिव नेगेटिव. फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स फॉर ओपन सिस्टम इन अनस्टेडी फ्लो प्रोसेस, ये वाला इक्वेशन ऊपर वाला ये. फॉर कंट्रोल वॉल्यूम, चेंज इन एनर्जी मतलब मोस्टली इट इज इंटर एनर्जी विच इज चेंजिंग. सो दिस एंड yeah, this is the first law of thermodynamics. Initially it was like this: h1 plus half v1 square plus q is equal to h2 plus half v2 square plus w. So now these are not both equal, so it is case like this: plus mihi plus half mic square plus this is equal to some energy stored plus some energy exited. If we take this here, the entry energy is equal to some accumulated plus this thing. Now the equation is pure unstable. So the equation should be written as this is equal to stored plus this. Now there is no confusion. The most asked question is this: supply line. Here pressure for the tank final will be equal to the supply line. It is automatic होगा ही. Suppose in final इस पे बस m2 मास है, initially m1 मास था, तो m2 u2 is equal to m1 u plus half m2 minus m1 v square plus m2 minus m1 h pipe plus heat added to the control volume plus work done on control volume. You take this with the sign: heat added to the tank, work done or removed from the tank. Take it with the sign. This is valid for reversible flow, irreversible flow. The previous one just now was also valid for irreversible, reversible, because it was energy balance, and energy balance is valid for irreversible, reversible. This is unsteady case. U2 you can write CPT2 only for ideal gases. Okay. H pipe is equal to Cp into T pipe. For discharging of the tank, this you have to see this, what the equation for this. So what is my final statement is integration P dV, it is valid only for reversible. Q is equal to W plus delta is valid for all, means only condition being closed. h1 plus half v1 square, all this equation is valid for steady, only condition being steady, maybe any flow, irreversible, reversible, any fluid. This energy balances at the moment are also valid for irreversible, only condition being unsteady. And the Q whole cycle is equal to work whole cycle is also valid for irreversible, reversible, both. So these are the general. PV raised to gamma is valid for reversible, not irreversible. So this is the end. This is the thermodynamics, an open system.